Hello! Today I'm going to show how to do partial fraction decomposition, but when the order of the numerator is higher or equal to the order of the denominator. So order is the highest power that appears, so you can see it's 2 on the top with the square, and on the bottom, if we were to expand these two out, we'd end up with 3x squared, so the 2 from the squared means it has order 2. So they've both got order 2, so they're equal. And what we have to do then is we do it kind of like normal, where we have the fractions where the denominator is the factors of this one over here. But we have to add on another polynomial with the order of the difference. So the difference between 2 and 2 is 0, so we need to add on a 0 order polynomial, and that's just a constant. So we'll call that a, plus then x plus 2 on the bottom, multiplied by b on the top, and then c over 3x minus 1. Very nice. Same step as normal then from now. We're going to make this on the right hand side equal to just one fraction with the denominator as the left hand side. So we'll have a lots of x plus 2, 3x minus 1, plus b lots of 3x minus 1, plus c lots of x plus 2. Beautiful. And this whole thing then is equal to the numerator, 9x squared plus 20x minus 10. So now we want to try and eliminate as many constants as we can from this. So of a, b and c, if we start picking the numbers inside this fraction, inside this bracket, that would eliminate the bracket, so x is equal to minus 2, for example. What we'll find is that goes to 0, this goes to 0, so we're left with only this term here. So we'll do that. Look at the left hand side now then. Minus 2 squared gives us 4, times by 9 is 36. Minus 2 times 20 is minus 40, and then minus 10. And on the right hand side, well, that goes to 0, that goes to 0, so we're left with only this b term in the middle. And if we see like minus 2 times 3 is minus 6, minus another one makes minus 7, there's minus 7b. And if we sort of evaluate this left hand side, 36 minus 40 gives us minus 4, minus another 10 gives us minus 14, so that's equal to 7 minus 7b. So when we divide by minus 7 on both sides, we're left with b is equal to 2. Do the same thing then, but for this bracket here. If you have x is equal to 1/3, this will cancel out to be 0. So this would be 0 and this would be 0, and we're left with only the c term. Beautiful. Look at the left hand side then. A third squared is 9, multiplied by 9. A third squared is 1/9, multiplied by 9 gives us 1. A third times by 20, we'll just say 20 over 3 for a second, and minus 10 on the end. Right hand side then, well 0 and 0, and we're left with 1/3 plus 2, which if we think 2 is actually 6 over 3, so it's going to be 1/3 plus 6/3 is going to give us 7/3. So that's 7/3 lots of c. And now if we think about this left hand side, well the 1 minus 10 will give us minus 9. Minus 9 is the same as minus 27 over 3. So it's 20 minus 27 is minus 7. And that all goes over 3 is equal to 7 over 3c. And then if we divide off by 7 over 3, what we're left with is c is equal to minus 1. Beautiful. Now then, we've got we've used both the terms, both the values for x that are going to cancel off this term. So we'll start comparing the coefficients. When we think about x squared, the highest power, on the left it's going to be 9. On the right hand side, well, if we expand this out, we'd end up with 3x squared. So it's 3, lots of a. Divide 3 by both sides, and a must be equal to 3 as well. So just to rewrite our fraction in one go, as the sum of the small fractions of the partial fractions, we'll have f, our fraction, is equal to 3, plus b over x plus 2, plus there, and b was 2, so that's 2 over x plus 2, and then c is minus 1, so we take off that fraction as well. 3x plus 1, minus 1, did that one wrong at the end, didn't I? 3x minus 1. Beautiful.